Here's the simplest possible circuit you could imagine. A source of EMF, a battery in this case, and some kind of electrical load, in this case a light bulb. What happens in this circuit? Well, charge, I've indicated charge at the positive terminal, flows through that circuit and goes from the battery's positive terminal through wires, through the external load, and comes back to the negative terminal. Now be careful. In fact, we know that the charge carriers in most common circuits, because they involve metallic wires, are in fact electrons, and the electrons are actually going the other way. They're coming out of the negative terminal, going the other way and into the positive terminal. That's what's actually happening, but it doesn't matter. The current is still in the same direction from positive to negative, and so I'm going to talk about circuits as though positive charge is flowing. It doesn't matter. It really makes no difference whether it's positive charge moving from the positive to the negative or negative charge moving from the negative to the positive. So charge flows from the positive terminal through the wires to the external load, through the external load, back to the negative terminal. What happens when it gets to the negative terminal? Well, if you think about the battery is maintaining positive charge on its positive terminal and negative charge on its negative terminal. It's doing that as a result of chemical reactions that occur inside the battery. So here comes this positive charge back to the negative terminal, and it experiences an electric field inside the battery which points downward from positive to negative. So how does it get back to the positive terminal? Well, that's the trick that the battery knows how to do. Chemical reactions inside the battery do work on that charge, and they lift it, like lifting a weight against gravity, against the battery's internal electric field, and they deliver it back to the positive charge, positive terminal, and of course they do so at the expense of their internal chemical energy, which is why the battery runs down and either has to be discarded or, if it's rechargeable, can be recharged. Let me give you a demonstration of a rather simple mechanical system that illustrates what in fact happens inside a battery. So over here I have a rather silly toy in which there's some penguins, and the penguins represent electric charge, and inside here there's a motor that is going to run a kind of escalator that's going to raise those penguins up. That's like the chemical action inside the battery lifting positive charge against the battery's internal electric field, and then the penguins are going to ride down this kind of slide, and that's like the external circuit. They're going to go through the external circuit, they're going to come to the bottom, and then that internal source of energy is going to again lift them. So here go the playful penguins. Being lifted by that energy, they reach the positive terminal, they slide down through the external circuit, return to the negative terminal, where the internal chemical reactions again lift them against the internal electric field, in this case lifting them against the field of Earth's gravity, and away they go. So there's a very simple mechanical analog of what goes on inside a battery.